Need a snap fit that just works? In this tutorial, I'll show you a fast fusion workflow for designing reliable snap fits that are ready for 3D printing without unnecessary complexity. Press S to open the design shortcuts and start a polygon sketch on the predefined vertical construction plane. Once the sketch is finished, press E to jump straight to the extrude command and extrude it 5 mm. That's thick enough to produce a strong part while keeping print times low. Press S again to access the shell command without interrupting your workflow. Shell the inside by 3 mm, leaving walls thick enough to accommodate the snap fit later. Next, press E to cut away the bottom. Set the extent type to all, so the cut automatically follows the full thickness if you decide to change the wall thickness later. Start a new sketch on the top face and create a center rectangle measuring 8 mm by 2.5 mm. I use the tab key to quickly switch between dimension fields, which speeds up the sketching process. This is also why we shelled the part to 3 mm earlier. It leaves enough material around the rectangle to create a strong, flexible snap fit. Press E to extrude the sketch. Set the extent type to all, so the cut automatically passes through the entire body even if you change the wall thickness later. Then apply a -10° taper angle. This taper creates the lead-in for the snap fit, allowing the mating part to slide into place before snapping securely behind the polygon frame. Combining solid and surface modeling gives you much more flexibility when designing functional parts. Here, I'll use the offset surface command to create a 0.2 mm clearance. For most FDM printers with a standard nozzle, this provides a good starting point for a reliable snap fit. Depending on your printer, material, and slicer settings, you may want to experiment with different offset values to find the best fit. Next, give the surface a thickness of 3 mm. This provides enough strength and stiffness for the snap fit while keeping the part flexible enough to engage. Then mirror it across the center plane using the new body operation. Creating it as a separate body lets us modify and refine this part independently before combining the design later. Now that the geometry is in place, switch back to the solid workspace and use the extrude command to extrude this isolated body 2 mm. This creates the locking feature that engages behind the polygon frame. Apply a -45° taper angle to create a support-free overhang that's easy to 3D print while still providing a secure locking surface. Finally, set the operation to new body so we can continue refining this feature independently. Fillets can improve strength, comfort, and the overall appearance of a part, and they're quick to apply with the F shortcut. Apply a 1 mm fillet, but don't spend too much time optimizing it just yet. The goal of this tutorial is to build a reliable snap fit. Once the design is working, you can revisit the fillets to optimize strength, ergonomics, and manufacturability for your final part. Press E to extrude the opposite end of the body. This time, leave the operation set to join since we don't need this geometry as a separate body. Our goal is to gradually combine these features into a single component while only keeping separate bodies where they make the workflow easier. Hide the polygon body to make selecting the remaining bodies easier and reduce the risk of misclicks. Hold Shift to select the remaining bodies, then combine them into a single body. With everything merged, creating a circular pattern around the horizontal construction plane is straightforward because the design is centered on the origin. I'll use 6 instances for demonstration purposes, but you should adjust the quantity to suit your own project. Now, repeat the same workflow for the cutouts in the polygon. Start by hiding the bodies you don't need, so it's easy to verify that you've selected the correct geometry. This time, change the circular pattern object type from bodies to features, because an extrude cut is a feature in the Fusion timeline, not a body. Finally, use the same pattern axis as before. Since the design is centered on that axis, the cutouts will align perfectly with the patterned snap fit geometry. Next, we'll use one of the lesser-known options in the extrude command. Start a sketch on the back face of the polygon and create a center diameter circle that just reaches the outside edge of the polygon frame. Make sure you reference the polygon frame, not the angled snap fit legs. Since the legs are tapered, using them as a reference would leave a gap between the circular plate and the legs. Now launch the extrude command and change the start option from profile plane to offset. Set the offset to 4 mm, then change the operation from cut to join so the new geometry merges with the snap fit legs. If the geometry becomes difficult to see, use the view cube to inspect the model from another angle. You can rotate the view without leaving the command. You should now have two separate bodies in the browser. Right-click each body and choose Create Components from Bodies. Keeping them as separate components makes them easier to manage later, whether you're positioning them in your slicer or adjusting print settings for each part individually. Right-click each component and choose Save as Mesh to export it as an STL file for your slicer. For this project, the default refinement settings produce excellent results, so there's no need to adjust them. If your project requires a higher quality mesh or different export settings, you can fine-tune the refinement options here. We're now in Bambu Studio, but the same workflow applies to most modern slicers. Import both STL files and when prompted, choose No to load them as multiple objects rather than a single object. This lets you position each part independently for support-free printing. Once they're imported, rotate the parts so their flat faces rest on the build plate. Then arrange them with enough space between them for a clean print. Thanks to the support-free design, you're now ready to slice and print. Your slicer will estimate both print time and filament usage, helping you plan your workflow and calculate production costs if you sell your 3D printed parts. From here, all that's left is to print, assemble, and test your snap fit. And that's it. A complete support-free snap fit workflow from Fusion to a finished 3D print. I'll also be publishing a written step-by-step guide on the Maker Letters website, so check the pinned comment below. I'll add the link as soon as it's available. If you found this tutorial useful, consider subscribing for more practical Fusion and 3D printing workflows. And if you'd like to support the channel even further, a super thanks is always appreciated. Thanks for watching, and I'll see you in the next one.